We need to solve the Cauchy's problem for Zp plus Q equal to 1 when the initial data curve is given to be this. X naught equal to mu, y naught equal to mu, z naught equal to half of mu, where mu is greater than equal to 0 and less than equal to 1. We need to find the value of z. So this is given to us that Zp plus Q equal to 1. We are going to make use of this. And let's take f to be equal to this, Zp plus Q minus 1. Now differentiating f with respect to p, we get z. Please remember, fp means partial derivative of f with respect to p, and fq means partial derivative of f with respect to q. So differentiating f with respect to q, we get 1. And now we need to check the second part of Cauchy's problem, that is this one. We need to check this condition to be non-zero, that is partial derivative of f with respect to q into derivating x naught with respect to mu minus partial derivative of f with respect to p into derivating y naught with respect to mu. This should be not equal to 0. Let's check this. Partial derivative of f with respect to q is 1 and derivative of x naught with respect to mu is 1 minus partial derivative of f with respect to p is z into derivating y naught with respect to mu is 1. So we are getting this to be 1 minus z, and z is mu divided by 2. So this is 1 minus mu divided by 2 for mu greater than equal to 0 and less than equal to 1, right? So this is not equal to 0. So this condition is satisfied. Let's move further on. So please consider these three equations. dx by dt is fp, dy by dt is fq, dz by dt is partial derivative of z with respect to x into dx by dt plus partial derivative of z with respect to y into dy by dt, right? So let's use these characteristic equations and also the initial conditions to get the value of z. So from 1 we get f of p to be equal to dx by dt. So z is equal to dx by dt. And then from 2 we are having fq to be equal to dy by dt. So from here we get 1 to be equal to dy by dt. That further implies if we integrate both the sides, we get y to be equal to t plus constant. Let me take that constant to be c1. And from third equation we get dz by dt to be equal to partial derivative of z with respect to x into dx by dt plus partial derivative of z with respect to y into dy by dt. We know that the notation for partial derivative of z with respect to x is p, because z is the function of x and y, right? So partial derivative of z with respect to x is always equal to p. This is the notation. And partial derivative of z with respect to y, we take this to be q, right? So writing here the partial derivative of z with respect to x to be p into dx by dt, that is from 1 we write dx by dt to be fp. So writing here fp plus partial derivative of z with respect to y is q into from 2 we write dy by dt to be fq. So this is fq and is equal to p into what is fp. So writing here z plus q into this is 1. So we are getting pz plus q. So this is dz by dt, that is coming out to be pz plus q. And what is pz plus q? It is given to us the initial condition, that is zp or pz plus q is equal to 1. So let's use this condition. So this is equal to 1. So we get dz by dt to be equal to 1. And if I integrate both the sides, we get z to be equal to t plus the constant c2. So z is t plus c2, right? So we have got our y to be equal to t plus c1 and z to be equal to t plus c2. We need to find these two constants. What are the initial conditions? x0 is equal to mu, y0 is equal to mu, and z0 is equal to mu divided by 2. Very fine. Okay. For the initial conditions, we take t to be equal to 0. So for t equal to 0, we are having these conditions. So from this we get y equal to t plus c1. When applying the initial conditions, y0 is mu and taking t to be 0 plus c1. So that means we are getting the constant c1 to be equal to mu. Right? Similarly, if I take this equation, that is z equal to t plus c2, applying the initial conditions, z is mu divided by 2, t is taken to be 0, plus c2. So here we are getting the constant to be mu divided by 2. Putting the values of these two constants over here, we get y to be equal to t plus mu and z to be equal to t plus mu divided by 2. Very fine. Okay. Marking this as 1. We have also got one more result, that z equal to dx by dt. We have got the value of y, we have got the value of z. The remaining part is, what about z equal to dx by dt? We need to get x. Now, z equal to dx by dt. Using this value of z over here, we get t plus mu divided by 2 to be equal to dx by dt. Or we can write dx is equal to t plus mu divided by 2 dt. Integrating both the sides, we get x to be equal to, this is t square divided by 2 plus, this is mu t divided by 2, plus the constant c3. And now we are going to get this constant c3 by again applying the initial conditions over here. So we have got our x to be t square divided by 2 plus mu t divided by 2 plus c3. When applying the initial conditions, we know that x0 is mu, y0 is mu, and z0 is mu divided by 2, but we need only this. And with this, we have to take our t to be equal to 0. So applying these conditions over here, we get mu equal to 0 plus c3, and we get c3 to be equal to mu again. And now let's put the value of constant c3 to be mu over here. So we get x equal to t square divided by 2 plus mu t divided by 2 plus mu. And also we are having y to be equal to t plus mu or mu plus t. And now from these two equations, we need to get the value of t and mu in terms of x and y, because we need to find the value of z, right? Finally, we need to get the value of z. So we can put the value of t and mu over here in terms of x and y so that we can get our z. So solving these two equations to get the value of mu and t, I'm writing these equations again. From here we get t to be equal to y minus mu. And let's put this value of t over here to get the value of mu. So x is equal to y minus mu whole square divided by 2 plus mu into y minus mu divided by 2 plus mu. So solving this further, this is y square plus mu square minus 2y mu plus mu y minus mu square plus 2 mu, and writing here 2x. So these two cancelled out and we have 2x to be equal to y square minus 2y mu plus mu y gives minus mu y plus 2 mu. Taking this y square to the other side and taking mu common from these two terms, so we get 2x minus y square to be equal to 2 minus y into mu, and from here we get mu to be equal to 2x minus y square divided by 2 minus y. Or we can also write this as x minus y square divided by 2 divided by 1 minus y divided by 2. So this is the value of mu and marking this as 2. And now we need to get the value of t. Now again from these two equations, let's take from here the value of mu to be y minus t and putting this value over here. So this is x equal to t square divided by 2 plus y minus t into t divided by 2 plus y minus t. So this is x equal to t square plus yt minus t square plus 2y minus 2t, and here I am multiplying x with 2. So these two cancelled out and we get 2x to be equal to, I am writing this first, 2y and taking t common from these two, plus y minus 2 into t. And now taking 2y to the other side and y minus 2 in the denominator. So this is 2x minus 2y divided by y minus 2 to be equal to t. If I take 2 common from the numerator and also from the denominator, we get in the denominator y minus 2 minus 1 equal to t, or it can be written as y minus x divided by 1 minus y divided by 2 to be equal to t. So we are getting the value of t to be y minus x divided by 1 minus y by 2, right? So from 1 we have z equal to t plus mu divided by 2. We need to put the values of t and this mu in this z. So if I mark this as 3, so from 2 and 3 we get mu to be equal to x minus y square divided by 2 divided by 1 minus y by 2, and t to be equal to y minus x divided by 1 minus y divided by 2. So we have z to be equal to t plus mu by 2. From 1, putting the values of t and mu, okay, so this is y minus x divided by 1 minus y divided by 2 plus this is x minus y square divided by 2 divided by 1 minus y divided by 2 into 1 divided by 2. When you solve this, so we are getting this further to be 2 into y minus x plus x minus y square divided by 2, and in the denominator we have 2 into 1 minus y divided by 2. We can also write this denominator as 2 minus y. So this z equal to this value is the required solution that passes through the initial data curve, right? So z is equal to 2 into y minus x plus x minus y square divided by 2 divided by 2 minus y is the required solution. Passing through the initial data curve and hence the solution. Okay, thank you. Stay blessed.